Good morning, all. This is Purnima Magalingam, and you're watching video lecture series on protection switchgear. Come, let's go into the video. So, in last class, we are discussed about induction relay and what are the important terms and the functions of relay and types of induction relay. We have a main four type, that is induction type overcurrent relay and induction type reverse powers relay, direction relay, and differential relay. So last class we have discussed about induction type overcurrent relay and its operation and working. Okay. So now we are going to discuss about induction type direction relay. So come, let's go into the video. Sorry. This is induction type directional power relay. This type of relay operates when power in the circuit flows in a specific direction. If the current flows in a specific direction, this type of relay operates. Okay, the construction details. Coming into the construction details, it consists of an aluminum disc and etc. Sorry. It consists of an aluminum disc is free to rotate in between the poles of two electromagnetics. So the upper electromagnetic carries the winding called as an potential coil, and the lower one is called as an transformer is called as an current coil. Upper coil is an potential coil, lower coil is an current coil. This is what the lower winding, the lower electromagnetic is called as an current coil. The upper electromagnetic is called as an protection coil. So here coming to the formula, the torque is inversely proportional to flux produced in first coil and flux produced in second coil with sine alpha. Here we can see that total torque produced, the force produced to rotate the aluminum disc is torque is directly proportional to the flux produced in first coil and first upper coil, flux produced in lower coil in terms of sine. Yeah, the F is phi 1 is directly proportional to the voltage, and phi 2, that is phi 1 is in potential, the upper coil is in potential coil, so it is directly proportional to the voltage, and the lower coil is current coil, so directly proportional to the current. So with an angle of 90° minus theta. So the total torque is V. Now we are going to replace this phi 1 and phi 2 by with voltage and current V and I. So the total torque is directly proportional to the voltage and current with the angle of 90° minus theta, with an angle of 90 minus theta. Okay, fine. So that this is the power circuit. When the power in the circuit flows in the normal direction, the driving torque and the resultant torque due to the spring, the driving torque and resulting torque due to the spring helps each other to run away from the moving contact from the fixed contact. Consequently, the relay remains inoperative. Then at that time, the relay remains inoperative. Okay. However, the reversal of current in the current reverse direction of the drive torque on the disc. Whenever the reverse driving torque is large enough, then the reverse driving torque is large enough, the disc rotate in the reverse direction and move contact close to the trip, and the disc rotate in the reverse direction and move contact close to the tripper circuit. This causes the operation of the breaker to connect with the fault circuit, break the disconnect with the fault session. Okay. Here we can see the diagram. Here we can see this is the potential coil. It's the current coil. This current coil energizes from the current transformer. Potential coil will be energized from the potential transformer. This is what an aluminum disc. This is what an aluminum disc. This is the trip to the circuit breaker. When this potential coil is energized, the flux phi 1 is produced. Here the current coil energized, flux phi 2 is produced. Flux phi 2 is produced. We can see the flux phi 1, phi 2 is current, flux phi 1 is voltage. So the difference between this is an angle theta. The difference between the angle voltage and current is theta, and difference between the current and the flux is alpha. So alpha, the difference between the current produced from the current coil and flux produced from the voltage coil. Flux phi 1 is produced in the voltage coil. That is, the flux is alpha. This flux is alpha. So when it get energized, what happens? The electromagnetic force from upper side and from lower side, we are getting the electromagnetic force. Because of this force, the torque produced, and then this disc starts rotating. This disc start rotating. This is what an operation. Here we can see another coil. Here we can see the current coil and potential coil, and this current coil from current transformer. Here we have an overcurrent protection element. Here the overcurrent protection element, if the current is increased above the preset value, this current what happens, this current coil energized, and this potential coil is also energized, and finally it goes to the trip to the circuit. When this get energized, so we are getting the current from current coil, and get automatically it gets rotate, and it trip to the circuit. This is what a direct element. This is what a direct element. Here also we have a trip to the circuit. Here also we have a trip to the circuit. This is what an construction working of this induction type relay. Now coming to the last relay of distance type relay. So this distance type relay is a non-unit type relay. This distance type relay is a non-unit, sorry, non-unit type protection. This is a non-unit type protection. It is a high-speed protection and a simple to apply. It's a high-speed protection and simple to apply. It is widely used to protect the scheme, the protection of high and extra high voltage. Mainly, it is used in transmission line. So we know the transmission line is only in a high voltage transmission line. So it protects the high voltage transmission line. It is used in the carrier added distance scheme in order to the reclosing the schemes. Okay. Now coming to the type of distance relay, we have so many types of distance relay. Depends upon the VI ratio. We are differentiated into 5 types. One is impedance relay. Next one is reactance relay. Next one is admittance relay. Next one is mob relay. Next one is offshore relay. So in this first relay is very important, and we can see one by one in upcoming classes. So first one is impedance relay. So here we can see the impedance relay is a torque produced by the current element is opposed by the torque produced by the voltage element. Here the torque produced by the current element, oppose the torque produced by the voltage element. Here with the current transformer, it connected series with the transmission line, and potential transformer, it connected parallel with the transmission line. Here what are the both the torque oppose. Then relay will operate when the V by I ratio is less than the preset value. V by I ratio is less than the preset determined value. Okay, fine. Now, here comes the types of impedance relay. Here, the distance or impedance relay is essential on ohmmeter and operate whenever the impedance of the protection zones falls below a predetermined. We know that when it falls below the predetermined value, there are 2 types of distance relay used to protection power system, namely definite time and time distance. Definite time and time distance, which operate instantaneously. Definite time is operates instantaneously, fall up to the predetermined distance from the relay. Next, time of operation is proportional to the distance of the fault from the relay point. A fault never near to the relay which operates is earlier than the fault far away from the relay. This is the time distance. Based on the time distance operations, it operates. Okay, fine. Now coming to definite distance, the type distance relay. So different distance type impedance relay. Its construction is consist of beam F and 2 electromagnet, and the armature of 2 electromagnet mechanical cup to the beam. The beam provide the bridged piece of trip contactor. The relay is so designed to the torque produced by the 2 electromagnetic oppose the direction. 2 electromagnetic is oppose the direction. Now coming to the operation. Here we can see the operation coming to this cheaper circuit. When this coil is energized, what happens is this gets attracted. This armature gets attracted. If it is get attracted, what happens? It will slide and it gets away from the triple circuit. Now this current coil, this get energized, what happens? This side, this armature get attracted. What happens? This moves this D moves this side, what happens? Opposite side, what happens? It connected to the triple. When the current coil gets energized, only this will trip to the circuit. So this is the basic operation of time distance relay. The time distance relay implies one which the automatically adjusts its operation time according to the distance of a relay from the fault point. Okay, this is what operation of distance relay. So the operating time, that is torque, is directly proportional to voltage by current, directly proportional to ratio of voltage by current, and V by I we can write as an Z impedance, and this impedance is automatically related with distance, automatically with distance. Okay, so this is what impedance relay, time distance relay. Here the same thing happens. Here the operation is from potential coil, this get energized. What happens? This get tripping. What happens here? The current coil is energized, and we have a spindle, and the spindle moves, and finally it trips to the circuit. Here the induction over current relays, this energize and this rotates, spring coupled, and finally trip to the circuit. Okay, this is what relay. So with this, we can end up with today's session. Next class, we can see another type of relay. Thank you so much for watching this video. Have a nice day. Thank you so much.